Hey everybody, Mr. Eiler here again. We're going to do a little more optics today. Hope you're having a fantastic day. Today what we're going to do is we're going to spend a little time talking about some of the images that we're making. And so far we've learned to make images with flat mirrors, concave mirrors, and convex mirrors by using ray tracing. We're going to learn kind of another way to do that today with some math. And yeah, and then we're done with mirrors, which is kind of cool. So, three things for today. We're going to learn a little notation. We're going to talk about different kinds of mirrors, and then we'll use some image equations. They're actually quite easy. I think you guys will enjoy them. Yeah, they're not bad at all. So you'll either need some straight edge and colors. Actually, you will for sure. Your old notes will be kind of handy. You'll be able to do a little writing right on them, perhaps for some of this. If you don't have your old notes, just some, you'll probably have to do a little more pausing than you might otherwise. Alrighty, so let's begin. So from last time, we had a convex mirror. And we had the three special rays coming off the tail of the cat told us where the tail of the image of the cat was going to be. And that's kind of what we came up with. Here's our new notation for today. We're going to call the distance from the mirror to the image S with a subscript O. That's that one. So from the mirror to the object. Sorry, I think I said image. So the distance from the mirror to the object, SO. S is going to stand for distance. The distance from the mirror to the image, S with a little I for image. Height of the object is going to be H with a little O subscript, and height of the image will be H with a little I. Now this applies to any object, any image, any mirror. Also it'll apply when we get to lenses as well. Okay, H's and S's. All right. One little rule about this. Excuse me. The object is always on the positive side of the mirror. Notice in this example, SI and SO are in different directions. So as always, we are going to have a positive and a negative. So for us, right here, that direction is going to be positive because that's where the object is. Also, the object is always standing in the positive direction. So in this case, up is positive as well because that's the way the object is sitting. And usually the object's upright, so up on the paper is positive. Remember, sometimes the images we get are upside down, in which case the image height would be a negative number. Okay. So far so good. Straightforward enough. That's all we have for that. This one is the same thing, but now notice the SO and SI are both going to be positive this time because they're in the same direction, but the HO and the HI is going to be negative in this case. All right, because it's in the opposite direction of HO. All right, so let's put our positive arrows on here just for fun. That's positive this way, and I guess that way is positive in this case. All right, straightforward enough. Easy. The same thing for flat mirrors, but remember I stole this from a book, so we don't use D's, we use S's. Okay. Again, the SI left would be positive in this case, so the distance to the image would be in the negative direction, but the object and the image are both in the same direction, so we're going to use up as positive, and they'll both be positive for us. All right, pretty straightforward. All right, here are our 3 examples so far. And this is the kinds of images that we're going to deal with. So this is number 2 on our list of things for today. An image can be inverted or upright. It's pretty straightforward. If it's in the same direction as the object, it is upright. If it is in the opposite direction, it's inverted. So let's do see if we can do a special little pen here. In this case, we have an upright image. In this case, the image is inverted, and in our last case down here, we have an upright image as well. Okay, next one. This one's a little bit tricky. Okay, so definitely pay attention. A real or imaginary image. Okay, here's the rule. I'm going to say this. It's not written down, so listen carefully. A real image, light rays are actually going to that spot. An imaginary image, there is no actual light rays from the object going to that spot. Let's have a look. This case right here. Notice the light from the tip of the tail of the cat hits the mirror and then bounces back to where the image is. That is a real image. Light is actually going there. Case number 2. Notice there's no light rays from the tip of the tail of the cat going behind the mirror. They bounce off and go off into space off to the right. So that is an imaginary image. Same thing with a flat mirror. Okay, last example. It's an imaginary image because there's no real light rays behind the mirror from the object. Okay? So 2 things, inverted and upright, real and imaginary. They're going to ask you about those on the test. Got it? Not hard. But you got to know them. So let's move on to number 3. The third thing for today, we're going to talk about 2 image equations. Let me cover these up and just show them to you one at a time, so they'll be a little easier to digest. All right. This one is called the Lensmaker's equation sometimes, but it says 1 over the distance to the image plus 1 over the distance to the object equals 1 over the focal length of the mirror. Okay, remember F was the focal length where light got focused. And the other one to remember is that the radius of curvature for a spherical mirror is always 2 times the focal length. So you're going to need both of those. So we're up to 2 equations now. So you guys, this is an easy equation. The only trick is be careful of fractions. Everything's in the denominator and it gets a little messy. The other equation, M. Are you ready? It's not written down anywhere, so listen carefully. M stands for magnification. The magnification of an image, okay, is the height of the image divided by the height of the object. It's also equal to the negative of the distance from the mirror to the image divided by the distance of the mirror to the object. All right. Nice, easy equations. Both of these are on your equation sheet. All 3 are on your equation sheet, so you don't need to memorize them. Let's practice one. All right. Here's our example from the convex mirror. Okay. So I'm going to write down our lens equation, and I'm going to just make a decision. Okay. The distance to the object and the distance to the focal point are about the same. So I'm going to call them 1, just to make our math very easy. Okay? And let's see what we come up with. So now notice the distance to the object is positive, because it's always the case. So in this case, for a convex mirror, the distance to the focal point has got to be negative. So I'll put in -1. Fill those in, and I want you to solve this and tell me the distance to the object. All right, so go ahead and pause the video and give it a try. All righty, here we go, step by step. There's filling in the numbers. All right. So now let's move the fraction that's on the left side over to the right. So 1 over SI equals -1/1 minus 1/1. Okay, so that's really 1 minus 1 equals -2. Okay, so you got to kind of be good with fractions with this stuff here. Let's move SI over to the other side. So multiply both sides by SI, and we get 1 equals -2 SI. Bring the 2 back over to the left side of the equation, and we get SI equals -1/2. And if we look up at our picture, lo and behold, look at that, SI equals -1/2. About. It's about halfway. So again, I was just making up these numbers. They're not exact. Now, let's do our magnification equation. How big is that image? Well, we don't know the heights, but we do know SI and SO, so let's plug those in. Magnification equals negative SI over SO. SI is -1/2. SO is 1. So we get minus -1/2 over 1 equals 1/2. Magnification is 1/2. So it's half as big as the object. And there you go. About half as big. So, very important idea here. This is the big one for today. These two equations that we used, the 1 over SI, 1 over SO, and the magnification equation, can confirm what you draw in your image diagram. All right? So, if we had gotten a magnification, for example, down here at the bottom that was negative, that would tell us the image was inverted. It was upside down. Okay? All that we did with these equations, with the math, is confirm what we draw with our ray diagrams. Okay? So it's actually a really good tool, if you're not sure you did it right, to go ahead and, if you use the math, to go back and use the ray diagrams and vice versa. Okay? So, excuse me again. That's our, that's it for today. I think we made it through everything. We got some notations, the H's and the S's, kinds of images, upright, inverted, real, imaginary, and we learned 2 new equations. So here's your video lecture problem. It is doing the same thing we did with the concave mirror, okay, using our ray drawing, but we're using math now. So notice one thing, I do have a hint here for you. So we're going to be using some algebra. So do that. And go ahead and try this. So stop the video, give it a try. See if you can do this before I show you the answer. Alrighty, and here comes the answer. Pause me quick if you don't want to see it. And there we go. Have an awesome day, everybody. Bye-bye.